Hello guys, welcome to the channel. I hope you all guys are fine and doing great. Today we are going to discuss this container with most water problem of GFG. So let's move on to the problem guys. We are solving after many days because of my placement season going on. So give a look to the statement. So here we are given n non-negative integers a1 to n. Basically what the problem statement says, we are given a wide range where some vertical lines are given, some n vertical lines, okay, and the distance between any two vertical line is 1, okay. But like that distance between, suppose this is I, this is ith, this is jth, so it's index 0 1 2 3 4, it is 0, so the horizontal distance between any I and j is equal to j minus I, that is 4 minus 0, that is 4. You can check 1 2 3 and 4, okay. So the 4 distance, and now what we have to find out, we have to find out the maximum number of water we can store between this. So what is the maximum amount of water? Let's take color of water. So maximum amount of water we can store between this and this. We can store any amount of water, but after if water comes above this particular level, because there is a wall but there is no wall at this particular side, so water will go on flow there. So the maximum amount of water we can store is up to height this, and width is equal to this. Oh, sorry, up to height this is the minimum height, and this is height, this is length. So the minimum amount of water is, suppose this is one height into one length, it is 1. The amount of water stored between these two are, suppose this and this are, the base means the width is equal to 2, 1 and 2, and the minimum height is this minimum height. So we can store water 2 into height of this. Suppose this is x, then it will be x. So guys, what we need to do, we have to find out the maximum amount of water we can store. The maximum amount of water we can store. Now how we gonna to find it, guys? How we gonna to find it? Now there are many ways, like we can use like n square approach here, trying for each possible pair. What is the n? N is 10 raised to the power 5, so this will not gonna to work. Okay guys, so now what we can do, I am going to try in on, but how? I will take a L pointer here, just erase these all bullshit, not bullshit but important to explain. This is an easy problem once you got to understand like what we are actually doing. Suppose this is j, this is I. So what we are doing, we are try to solve for maximum number of width, for the maximum number of width. Then in each step what we're doing, we will decrease width by 1, width by 1. How 1? Either we shift I toward its, either we shift j toward it. Okay guys, so we will move this. Now how we gonna to do this? Now guys, as we fix that there are two components on which my amount of water stored between any two vertical lines depend. What is the quantity will depend on height into width, and we have to make this maximum. So for this to be maximum, what we need to do, we either increase h, we either increase w, or we increase both h and w. But here, because we are moving I and j toward each other by one step, so it means we are gonna decrease w in each move. So either to make q maximum as possible, what we need to do, we need to increase h as much as possible. Okay guys, so what we will do, we will move that particular ith or jth index whose value is minimum, why? Suppose I am giving you an interesting example. Suppose its height 1, its height 2, 1, suppose it is 3, 1, it is, suppose it is 2, it is 1, suppose it is 2. Now we are initially at here and there, so the maximum amount of water storage, this is index 0 1 2 3 4 5 6 and 7. 7 minus 0, that is 7. The minimum height 1 and 2 is, the minimum amount of water we can store here is this, okay. Like between these two walls, if we consider these two wall, then minimum amount of water we can, maximum amount of water we can store is this, because after this water will overflow from here. So it is 1, so 1 into 7, it is 7. Now guys, if we move j here, then we can see we will go w decrease by 1. means 6, and the minimum height will be 1 and 1, because we already have its minimum height. So we are gonna to like, if j is as bigger as possible, but the minimum height can be up to this. Okay, why? Because I is this, j is this. Now because we are taken height as minimum, so minimum is this. Now in next move, if we move my jth index, height will be more bigger, then it will not give us any effect. Why? Because when I will take minimum of this and this, I will go to this always. And if my j is smaller, then it does not care, it will gonna to minimum my it will gonna to give me minimum amount than previous. Why? Because my w is already decreased by 1, and now we are saying j is also decreased. Okay, so h also decreased, w also decreased, so q will also be the minimum than previous. Okay, so what will be our focus on? Our focus should be on whatever be the minimum side, either it is the is side or either it is a js side. I will, if this is, if the minimum one in among I and j is ith, then I will move I one step forward. If the minimum one is j, I will move j one step forward. Okay, because it may uh, possible, like this is I, this in j. If we move this, like here, take this example, if we move I here, you can see we will go to here, to here. Distance between them is 7 minus 1, 6. Height, minimum height is 2, so 7 into 2 is 6 into 2 is equal to 12. So we will go quantity, instead of 7 we can go 12. Now both are equal, so we can either move I, we can either move j, we can either move I, either move j. It is completely on our approach. Like, we can do anything. Like suppose we are decreasing it again to 1, we will go to minimum, because w also decrease, minimum also decrease. Now this will gonna increase. Okay, you can see now 3 and 2, 7 minus 3, 4. Minimum of 2 and 3 and 2 is 2, so it will give us 8. We already have 12. Now we will gonna to move this 2, because now ith is greater, so we'll gonna move this. W decrease, 3 and 1, 1 decrease, so we will go to minimum than this. Again move this. Now 3 and 2, you can see, like from 1 we are going to maximum. Okay, so if my ith is minimum, suppose my jth is minimum, so we are moving ith in hope that maybe we can go to some maximum, we can go to some other maximum that will gives us more bigger amount of outer. Okay guys, this is what we are gonna to do. Just make some sample cases for understanding is in better way, because self understanding is the best way of understanding an algorithm. When I do it first time, I was also not able, like, why we are moving I and j only one step. It may be possible than any mid value we have to take, but that mid value will come in consideration, because each vi will always come in consideration at least once. Okay, and it will gives me the maximum answer. Okay guys, so now we will take L and J, L and R. Now while my L less than R, why? If suppose if my L is this, R is this, then W will become 0. That's why. So answer is maximum of answer, and 1 LL means it will convert it to long. Okay, maybe multiplication can be go up to my int value, so I will take long. Now, absolute value means the width difference, and the minimum of height means the minimum of difference between minimum height of VL or VR. Now, if my height of LH is greater than VR, means RH is small, so we will move RH. Else while means my LH is small, I will move LH. And at last, I will just return my answer. So this is simple approach, just 5 or 6 line code. 6 line actually. So guys, you can see all the 150 test cases pass out. I hope you all understand the problem. If you have any doubt, then just comment out. I will try my best to explain you. Please subscribe the channel, like the video, and check out my channel for more this type of videos. Thank you for watching this guys. Stay tuned.